And I am live. That is pretty cool. Today is 28th of October 2025, Tuesday. And with that, let's just begin. Yes, change the screen. Yes, nice. Stop the video. And yep, here we are. Code forces. Yep, there was yesterday there was one question specifically which we weren't able to do. And not because we didn't know what to do in that question, but more specifically, we were unable to remove an element, like some semantics related to policy-based data structure. And the question was, I think, something love. Yeah, in love, this one. Yep, this is the exact question. And the problem that we were facing here was that here, if I, uh, yeah, start Emacs attach ECP target SCP and start in love. Yeah, this one. Here we are using a policy-based data structure, and this step which you are using to get a iterator to the element and then erase the element from right and left, this is somehow not working. Wait, shit. IT, like get an iterator or remove the iterator. Wait, shit. If this works now, that would be pretty crazy. Okay, no, and this is still not working. Yeah, we are getting negative value. We should not be getting negative value. Okay. CNT dot size does not mean anything. You can just do left dot size to get its size. And yes, size is decreasing. Okay, size is decreasing at some point. Okay, shit, that is very nice. But why did it not? Why is it only decreasing in some cases and not in others? IT, lower bound L in left and erase the iterator from left. Okay, let's print the whole thing for auto IT in left. We will print left, cout IT space. Okay, let's see. Okay, so left is decreasing. Shit, my bad for white light theme. Here in the first four steps, the size should be increasing. We add 1, 3, 2, 2, and then 3. So 1, 3, 2, 2, and then 3, right? But after this, we do remove 3, so, but 3 was not removed, so that is a problem. And then also in the next step, nothing was removed, right? 3, but then shit, then we removed a 2 instead. We should be removing a 1, so that does not make sense. Lower bound, why did we remove a 1? 3, lower bound. Is lower bound not working correctly? Shit. Wait, are we seeing this as -1? If we are seeing this number as -1, that would be crazy. That would actually be crazy. Left, and then R, and then not a new line, but space would do. Okay, no, we are not seeing these numbers as minus numbers. So yeah, that is nice. So why are we unable to remove this thing? Find, okay, we can use the find function, but that would be very, very slow. And yes, that would be actually very slow. Lower bound r dot lower bound r. So we should get an r from right. And in left, when we are, let's see, we will print these, and here we will have a colon. Okay. So yep, here we added, and then we are looking for 3 and 4. Yes, we are looking for 3 and 4. We are looking to remove 3 and 4. And on the left, we do have 2 3s, but we do not remove them somehow. Somehow, I don't know why we don't remove them. But the answer does change. The answer does change somehow. Okay, shit. Answer is changing depending on the count. Yes, answer is changing depending on the count. But this is not being reflected in the policy-based data structure. 3 and 4. Okay, shit. Here we have minus 3 and 4, so we should be removing 3 and 4, but they are not being removed, even though we are finding an iterator to 3 and 4 here. Okay. These 2 steps are perfect, but these 4 steps, they are the ones which are not working. R dot lower bound. We get a lower bound in right to R. Yes, which is right. Let's see what these values are. So when we have a iterator to the lower bound, let's see what the value is at that iterator in the right. Okay, shit. 0, 0, which does not make sense. 0, okay, shit. 0, 0 does not make sense. What is the R value? R value is 3, 4. R value is 4. 4. 4 is okay. Let's here, instead of left, we'll print right. Okay. 4, 4. 4 is the R value, and we are looking for a value. R makes sense. And here, let's see what the value as the iterator is. Okay, it is 0. 0 is completely wrong. 0 does not make sense. Yeah, 0 is wrong. We can use ChatGPT for this. Like, yes, I am using a policy-based data structure to store information in C++, and the comparison function is less than equal. Yeah, that is the comparison function. Uh, how can I events, because we have used the things which were on Stack Overflow and other places, but they did not work. So let's see how it goes here. Less than equal to correct way, emulate multiset behavior. Emulate multiset behavior. Okay, if you want to allow duplicates and still remove elements safely, the standard way is to store pairs, value, value, unique ID, and use less pair as the comparator. The core problem, you are likely using this thing. Is this what we are using? We are storing type T, null type, yes, less than equal to. Yes, we are using this. Yes, that is exactly what we are using. Tree order statistics node to get order of a node. That is, how many elements is this current number bigger than. The issue is that less than is not a strict weak ordering, and the tree container requires that property to work correctly. Okay, so there is some internal problem with the tree. Strict weak ordering means strict weak ordering means compare this is always false. If A comma B and compare B comma A are both false, then A and B are considered equal. That makes sense. Less than equal to violates this property. It allows this to be true. Okay, so you will end up with undefined behavior, which is what we are facing. So there is some bigger problem. Hello. Shit. You are the editor? Wait, why do I have chat at like two places? Uh, Pop out chat. Yes, that is nice. Much better. And okay, so there is some like bigger internal problem with the data structure itself when we want to simulate a multiset, that is have multiple numbers, multiple things have the same value in a set. If you want to allow duplicates and still remove elements safely, the standard trick is to store pairs, value, unique ID, and use less pair as the comparator. Okay, so the thing that is the problem is the comparator that we are using here is this one, less than equal to, which is like defined in the standard library, and LSP start lang d and shit, no location found, no location found for this thing. Wait, LSP stop. So yeah, and this comparator function, it does not have strict weak ordering, which is defined here. They are saying what this tree requires is something, the comparison function which is required by this tree should be like this. If we compare the same value by the function, that should return false. And thus, when the tree wants to check if two elements are equal or not, the tree checks this thing, A, B. If this thing is false and B comma A is also false, then E and B are considered equal. That is what the tree wants, but we don't have it, which is bad. So the correct way to emulate multiset behavior is we can use a pair, right? And use the less operator for a pair. And since we will be using pair, the first value can be the value which we want to store in our multiset, and the second value can be a unique ID, which is unique for everything, which we can simulate by just taking, yeah, a counter, and we will increase it by 1 every time that we insert something. And then we can also easily erase something. Lower bound and finds first 10. That makes sense. Okay, shit. Okay. That is what we need. So, okay, that is what we will have. Pair of integers. And on this side, we don't have to change anything because this is a generic function. We're using t. So that is nice. And for the unique ID, we'll say int u ID initially equals 0, and whenever we were inserting new things, we will say we will insert instead r comma u ID and plus plus to just increase the value. And yes, let's just, yeah, integer is fine. Integer is fine. L and u ID plus plus cool, and here, right, when we are looking for something, we'll say r comma 0 to get the first occurrence of this r, and then delete that thing from right. And in L, we'll do the same thing, L comma 0. That makes sense. And here, instead of L, we'll say L comma 0. Right order of key, yes, L comma 0 makes so much sense. And here, we'll say R plus 1 comma 0, which also makes sense. And we'll do the same things here, L comma 0 makes sense. and here we had r plus 1, so we will say r plus 1 comma 0 to make this a pair, where we are just defaulting the second value to be equal to 0. Okay, shit. Yes, because the iterator now is not a single integer. Let's go. Okay. Now just for checking, we'll say left dot size. We will always see the size just for testing purposes. Okay, size is changing, which is a very nice thing. And at the end, the size is equal to 0. Okay, now, so yeah, cool. Now we are done. This is working. That is pretty cool. What is the green colored extension? I've seen a lot of CP folks using it. Can you tell me about it? Yep. Wait, green color extension? This one. This one is called Codeforce's Companion, Competitive Companion. And I do not understand how this internally works, but its main purpose is whenever you are on a problem page like this one, here we have a problem, you can click on this thing, and I think what happens is this thing then sends a signal to some process which is running, or your text editor here, which is Vim. And in your text editor, there must be an extension which is listening for whatever message was sent by this. And the extension in your text editor which is listening for the message which is sent by this extension, that message contains these problem input and expected output, so that you can test if what code you have written, it is right or wrong. So yeah, but I don't know how they like communicate with each other. And my guess is there might be it's very specific port on which this extension on the text editor side is listening, and on that port, this extension sends the request, or like sends the message which is captured by the extension here. So I think that is what is happening, and shit, this thing works. So that is nice. Now what we will do is we will remove the whole thing. Yep, remove the whole thing, and we will write the whole thing from scratch again. There is a key map which I have added, snippets, and policy based PBDS. Yes, and I have to write PBDS to get the whole thing there. Okay, cool. Okay, and here if I write PBDS, yeah, the whole code is here, which is pretty cool. And here we are creating a new data structure. We are calling the tree function, or class, the tree class, with all of these parameters in the template. T is the type that we are going to store, and less than, we are not going to use less. Okay, no, we don't have to do anything here. Now we just take in the input vector in a size n for int, not capital, int reference x and a c n x, and yes, now we have the whole thing. Now we need a data structure. Wait, shit, this is not even, shit, this is like not even close to the correct answer. And q, the first number that we have is the number of queries that we have, right? And we will have a counter, which is the number of pairs initially, which we can choose so that they are like disjoint, right? Makes sense. Hello, good afternoon. How is everything going? Count. And then we will create our data structure. We will call it, before calling it, we will have to create it tree, and it will store pair of integers, and we will call it s. Makes sense. And now for queries, while q minus minus. And shit, like this is wrong. Why is this wrong? Because we do not have multiple test cases. So this thing goes here without the solve part. Okay, and yeah, here we will have a character C and int L and R. Mm. Int L and R, and we'll take in C, then L, and then R. And if C equals like plus, then we have something to do. And if minus, then something else. Okay. If C is a plus, then we are adding this new thing. Right, we are adding this new thing, and we have to see with how many available, with how many segments which are already in the with how many segments which are already in the like total multi-set of segments can we pair this current one up with, so that the so that yeah, they are disjoint. How many new disjoint pairs are created accordingly with this question? Yeah. So to test that, the left part of this new segment has to be greater than the right part of the segments with which we pair this up. That is one way. So CNT plus equals in S dot key by order or order by key, order of key. What is the key? Key is left, which gives us how many things is L greater than. That is nice. And then how many things is R, the right segment is smaller than or is greater than, right? What we need, so here is how many segment is the current one on the right of, that makes sense. And this one is for how many segments is this new one which we are adding is on the left of. And what we can get is order of r plus 1. Order of r plus 1 will give us r plus 1. How many things is this r plus 1 greater than? Or shit, we are not doing this on s. S does not even make sense here. We have two things, left and right. Here for left, this left has to be to the right of all the right elements. And how many things, how many left values are smaller than r plus 1? And if we subtract this number from the total size of left minus this, that will give us how many left values are greater than r, right? That makes sense. And then also we will insert right dot insert and shift, since we are storing a pair, so we will do l comma 0 and here r plus 1 comma 0 because of pairs, and r comma 0 and left dot insert l comma 0. Makes sense. Yeah, makes sense. But if the current operation was a negative, then we will have to subtract the same value. Instead of minus, we will have to subtract. Makes sense. And then we will remove these values from left and right, for which we will first get an iterator, right dot lower bound r comma 0 and right dot erase the iterator and id equal left dot lower bound for L comma 0, and then left dot erase the iterator and its and now cout depending on CNT. If CNT is greater than 0, then output yes, otherwise output no. Okay, shit, we messed up somewhere. Wait, shit, this has to be question mark. Okay, uh-huh. This is yes somehow. Why? What is the value of count? Count is equal to 0, 1, 2, 3, and why is it still 1 in here? Left dot size minus how many things on the right are smaller than left? Then the left that we are removing makes sense. So that is completely right. And this one left dot size is total things on the left and things on the left which are smaller than r plus 1, which are smaller than r plus 1. So yeah, they are like yes overlapping. Yes, they are overlapping. Wait, shit, this doesn't make sense. Order of key, lower bound, remove left and then remove right, and then depending on CN. Wait, shit, this should be working. This is not working. Hello, professional CP guys. Are you solving policy-based problem? Yeah, this one is a policy-based. I mean, we need to store elements in a sorted way, and also we need to know how many elements is this given current element greater than, which is the order of a element. So that is pretty nice. Policy based. Yep. Hello, I am amazing. How are you? Six is a nice number, like 2 into 3. And shit, yeah, I think you should also do this question. This question is pretty nice. Yep, header file makes sense. We have to include all of these crazy things using namespaces. Wait, I did this twice. That was fine. And also, let me show you. I mean, shit, I think you did saw this. This is crazy. Yeah, you can just include things like this. If I write PVDS at the bottom and enter all the code related to PBDS, policy-based data structure is here, which is like, yeah, very cool, very cool. NeoVim, but this some shit makes sense. We are not, when we are inserting these elements, we are not giving them unique IDs, and therefore, as a consequence, yeah, things are getting messed up. Unique ID initially was equal to 0. Yes, because this is a multiset, we need multiple iterations of a value. So yeah, it makes sense. So when we are iterating unique ID plus plus, so that every instance, even if their R values is same, their unique ID will be different because it is always just increasing. And also integer is going to be enough because at max we have Q operations, and let's say all of them are just adding new values. So unique ID would just be at maximum 2Q, which is fitable in an integer. That should work, and that does work. Okay, cool. NeoVim, G, both are good. NeoVim is pretty cool. Do it in VS Code as well. shit, you can do it in VS Code as well. Still, new Vim is good. New Vim is better. New Vim is better. New Vim is better. Okay, this is running, and that is a like bigoted view. Even if you show me that VS Code is like faster or like there is everything in VS Code that is in New Vim and also easier to configure on VS Code as compared to on New Vim, I would still say New Vim is better. There is no rationality in this. Okay, why is this very slow? Is like something wrong with code forces? And of course, we have snippets. Shit. Ha. Yeah, but we have to remember all the shortcut keys. Well, you don't have to remember the keys that have been given to you. In Vim, you can configure the keys. Like when I press, look at here. I think, yeah, and things will appear here. Look here, in the bottom right, space C, P, P. This menu pops up. And I do not have to remember space CPP because if I go to the plugins, Assistant Vim, I can change this to anything I want. Leader means space and CPP, I can change this to anything I want, and so I don't have to remember. I can just make it as I want, which is like nice freedom. And okay, this one is done. This was nice. Let's look at the editorial. I think they also do this using policy-based data structure, which would be nice. Can give me all your plugins. Oh, can you give me all your, wait, you are also using Vim. That is pretty cool. Let me type the whole URL, https://.com/my name and nvim.rc. Go there. All of my plugins for NewVim are here. Like the whole NewVim config. Bro, in VS Code, we done. Don't have to do all this. Just tap on run. That is all. Yeah, but there is a lot of abstraction. Right? There is a lot of abstraction. Okay, shit. If you want to understand how Neuron works, then there is this amazing playlist by Mr. Viro. He's amazing. Like literally this guy, Viro, he is amazing. He reads Neovim source code. He goes to like GitHub, downloads git clone the whole code base of Neovim, and then reads the source code of Neovim, which is amazing. And he has this whole playlist about Neovim. You can check it out. I have watched this playlist like 3 times, and I have to watch this a few more times again to completely understand this. And this is amazing. You can start from here for new. Yo, yep, damn. He reads the source code. He is different, built different. And this one, wait, this was D in division 1, 2, and 3. That is crazy. At one time, raspberries. Look, shit, that is the whole thing. Let's learn how to solve the problem for a fixed set. The claim is that if the answer exists, we can take the segment with the minimum right boundary and maximum left boundary, maximum left minimum right boundary, okay, and maximum left boundary. Let's denote the Wait, okay, let's denote these boundaries as L and R. Therefore, if R is smaller than L, it is obvious that this pair of segments is suitable for us. Otherwise, all pairs of segments intersect because they have common points in it. Okay, shit, I admit defeat. We didn't have to use policy-based data structures. This solution is much smarter. Is it possible for me to become good at code? Yes. I just know Python syntax. Yes, you can. It does not matter where you are. What matters more is where you can be. Okay, so you can be really good. Like you can be one of the best if you work hard enough. Today I will learn NumPy. Any video I don't know about NumPy, you can NumPy there. NumPy documentation. Let's go. can read that. I don't know any YouTubers who go into the specifics of how these libraries work. NumPy. Okay. Free code cam. Uh, Maybe you can watch some of these videos. That would be nice. Bro code is nice. Bro code is nice. NumPy in 5 minutes. 5 minutes is not allowed, and the documentation is not loading. Here it is. To absolute beginners guide. Yes, you can begin from here. Absolute beginners guide. And yeah, I don't know why this is not loading, but yeah, you can start from there. Is a problem in CP 21? Should there are versions of this thing. How should I start? You can start solving questions. Just import NumPy as NP and do some shit. Get your hands dirty. And if you want to read, which you must read, you can go to the documentation. And how to start code courses. This is the thing. You need some place to look up questions. Shit, 5 minutes. Okay, CP31. That is nice. You need some place to look up questions, and this is a nice place to find questions easily at a rating. And you can start from 800 rating and see questions, start solving them, and yeah, you can go from there. And for theory part, you can read this book, Competitive Programmer's Handbook. That would be it that you, and I'm telling you, Sausha, Sosana. Shit. Okay, so let's implement their solution because that is like very smart. Uh, yep. Shit. Um, uh, Go to okay, here. We don't even have to use policy-based data structures. Shit, they are very smart. Shit, the thing that they have done is like actually pretty cool. And you take in you and we will take set of integers left and right and while q minus minus for each query we have a char c which we can define like right here and with this l and r and here we will say cn c l r and fc equals r plus then we will do something else we will do something else and if c equals plus we will insert left dot insert l and right dot insert right and the smallest in the right section and the largest in the left section if they are yeah after this and shit this has to be a multi-set which makes sense because we need multiple iterations of the same number and when we want to remove a thing from the multi-set we use auto we have to get a iterator to that value left dot lower bound for L and left dot erase this particular iterator and then it equals right dot lower bound R and right dot erase it. Okay, and now if the smallest in the right which is if go to right dot begin which is the smallest value in the right section and also size yeah right dot size there has to be some elements there if right Yeah, if we know that there are some elements, at least some elements there, then go to right dot begin, which will be the smallest element in right. If this value is smaller than the biggest value in left, which would be L left dot end minus minus. Okay, so what is the problem here? Lang invalid operands to binary conversion iterator. This thing is returning iterator. Okay, shit. If this is the case, then see out yes with a new line, else see out no with a new line, which is actually pretty cool. Yeah. And we don't even need policy-based data structure for this. Shit, this was a nice question. Nice instructive question, I would say. Nice instructive question. For okay, and what is the thing that we learned from this question? It is yes, go to 800, 900 second. Little problem. I will to learn C++. You can learn C++ or you can just do in Python. Experiment in Python. Yep, that is good. I think BenQ uses Python and he is in top 10 coders in Code Forces. Yeah. Mhm. Language. Yeah, language. I use C++ because C++ is difficult, and if I get really good at C++, I will also get really good with computing in general, and it will be very easy to switch from C++ to Python, and it would be comparatively difficult to switch from Python to C++, right? So yeah, that is why I went with C++. And it is up to you what you want to do, but the main point is just do something. And the thing that we learn from this is we just need to know not which pairs are intersecting. We just need to know, is there a pair of segments which we could choose which are non-intersecting? And if they do exist, then we can just take on the right smallest, right, the segment whose right right index is the smallest and the segment whose left index is the smallest. And if the left index is onto the right of the smallest right index, then there at least exists one segment which is non-overlapping, and that is what we wanted to know. Shit, shit, that is nice. That is nice. And also one more thing here is that we only have to know if such a pair like this and this exists. We don't need to know which one is the pair which we have to choose, that they are overlapping, and also not how many there are. So in this new method, we are only calculating if there exists one such pair, which is like nice. Yeah, we are only calculating the amount of information that we need. So that is nice. That's nice. Yep. Do something rather than wasting. True, true. Yeah. Yo, how is everything going on? And shit, where did you go to give your contest? Like, you went out of country, I guess. Okay. Here, hidden knowledge of ancients. I guess I didn't do that one. And let's do firewood. Or then maybe we'll do final boss. Mad, some fun. Maximize the root, expected mean, mean shit. Mean questions are kind of difficult. Okay, we will also have a stopwatch. Here, flew back from Sydney. Okay, to Melbourne. Shit, now I know where you live. Sydney. How is your contest? Didn't qualify to World Finals. Lost to last year's IOI Australia team. Ah, shit. Well, that is still nice. I mean, you didn't qualify for World Finals, but you like went to a whole different opposite side of the country to give a contest. That is pretty cool. Not. Wait, this was in Kotlin Heroes. Shit, I cannot choose anything else other than Kotlin. Shit, my bad. Let's start with the final boss then. Yeah, cool. DM, still crazy. Yep. You are facing the final boss. Okay. Final boss. We are starting from the final boss. You are facing the final boss in your favorite video game. The boss enemy has H health. Your character has N attacks. The ith attack deals EI damage to the boss but has a countdown of CI cooldown of CI turns, meaning the next time you can use this trick on his turn X plus CI if your current turn is X. Each turn you can use each turn you can use all the attacks that are not currently on cooldown all at once. Each turn you can use all attacks that are not currently on cooldown all at once. If all attacks are on cooldown, you do nothing for the turn and skip to the next turn. Initially, all attacks are not on cooldown. How many turns will you take to beat the final boss? The boss is beaten when its health is 0 or less. Wait, so greedy? Shit, we can just use greedy algorithm here. We have the attacks and yes, they are cooldown. So if we can make a move, we will make a move. This is like processor scheduling. And H is the health of the boss and the number of attacks you have. Okay, here this is the health and the number of attacks. I have 2 attacks, so shit in just 1 turn. The answer for this should be 1. Yes, it is. And for this, I need 2 turns. That is nice. And what is the maximum value? For this, we can just simulate this thing. We can just simulate. No, we cannot just simulate. We don't want to go through everything, all the turns again and again. Should we can use binary search? We can use binary search. Yeah, we will use binary search. This is shouting binary search. We will use, and yes, this is like exactly what you said. At some point, binary search on answer, right? Better to use all the tags at once so that we get the uh, moves back quickly. Yes, and we will use binary search to find the thing. And okay, int health and not u n and then vector of integer damage and count or CLD cooldown. Size for this is n and size for CLD is also n. Int I equals 0, I less than n. I plus plus for in reference x in DMG take into x, and here instead of DMG we will have CLD, and we will stop the LSB. Okay, and now in L equals 0, and the right answer, what is the maximum thing? Maximum would be h plus 1. That is the maximum time. And okay, we know that the answer is smaller than r because at least we will get 1 damage. Shit, we will not get one damage. What is the maximum amount of damage that we can get? The maximum amount of damage, let's say it is, or the maximum amount of time that this thing would take. Shit, there is no relation between N and H and this and this. So the maximum amount of time that this thing could take can be very, very big. And I want R to be a value which is always greater than the correct answer, and L to be a value which is always smaller than the correct answer. So L is always going to be 0, uh, because the correct answer is always greater than 0, because the health is initially always non-zero. So we will have to do some attack, and R we can say in maximum long. Let's restart blank D. Let's see restart long max C++ L long max. Let's restart, and okay, it is working. Yeah, cool. And after this, okay, while r minus L is greater than 1, int or long m equals L plus r minus L divided by G. Cool. And we need to know if m is the correct value or not. We'll write a function bool is okay, which will take in a long value m and damage and cooldown. Yes, vector of integers reference dmg and vector integers reference cld cooldown. So right, and also the like health of the boss h. Now we need to see how much damage is dealt. Initially equals 0. So for int I equals 0, I less than n, I plus plus, what is n? N is int n equals dmg dot size. And now, how many times is this current damage going to be applied? That would be del plus equals CLD, uh, the turn, which is m divided by CLD, m divided by CLD, m divided by CLD. Okay, if we are starting with 1, at least always we can do 1 damage, and okay, we can always do 1 damage at least. Then when will the second damage be? Ci, if x initially is equal to 1, right? For the first turn x is equal to 1, and then let's say cooldown is of 1, then the second damage will be at 2 at turn 2. And if cooldown is 2, then the second damage would be at turn 3. And the next one would be at, okay, 3. If cooldown is 2 and m is 4, 1, 2, 3, 4. At turn 4, we will do 1 damage. So yes, and then no here, and then yes here, and then no here. But if we divide this by 2, it does turn out to be this number. But if we do this, then we will do a damage here. So upper bound, we have to take the upper bound. Seems correct. Yeah, we have to take the upper bound because the interval at this, we do the thing at the start of the interval. So yeah, we have to take the upper bound, which is m plus CLD minus 1. That is the upper bound. That is how many times we will build the this current damage, which is dmgi. Now, if return delt greater than or equal to h, and now here if is okay, m with health h and with dmg and cld should, or I could have described these things as global vectors or global variables, and we wouldn't have to pass them like this. So which IDE should I try? I am currently using VS Code. For CP you can IDE. I mean, if you just want to use an IDE, then VS Code is good enough. But if you want to get something which is like much better, then you can switch to Vim. Hi, hello. Okay. And here, if this current number is okay, if this current number is okay, then we will say L equals this current number, which is M. Else, if this current number is not okay, then we'll say R equals M, because R is never the answer and L is the answer. And then when we are out, we will say C out L. That would be the answer. Hmm. Shit. Wait, CLD, CLDI, and okay, wrong answer. Shit, that is a little bit off. The answer is a little bit off. And wait, I'll be like right back just in a minute. I have to go to the washroom. I'll be right back. Now I get what is wrong. GVim, you can use GVim, the graphical version of Vim, but I would say go with this, the non-graphical terminal version of Vim, which is much better. I have installed it. I'm gonna set it up. Yeah, I mean you can start from here and then eventually you can move to the actual thing, and you can start from here. It is pretty cool. And shit, we messed up. We want shit. The thing here is like this on this number line. L is here and R is here. R is always true, 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 and L is always false. And at some point we see a true, the first true. We need the index of this first true. That is binary search. Okay, so if this is true, we'll say R equals L, R equals M. And if the current thing is false, we'll say L equals M. R equals with a little bit of space. That should work. Okay, should that didn't work? We will have to output R, because R is always true. R is always true. R is always true. R minus L greater than 1. Yeah. So R will be pointing to the smallest true. Okay, shit. I didn't expect this to fail. 1, why does this thing say 1? I think there might be some, this number might be just a bit too much. In max, let's say, shit, that number was actually too much, I would say. Okay, shit, this still doesn't work, and 1 does not make sense in any universe. R equals L, medium value equals this. If the damage that is dealt is greater than the health or equal to the health, then it is okay. If is okay, MH damage and see, okay, the first thing is the damage of your attacks, and the second thing is the cooldown. So yes, we are taking the input in the correct way at least. And the L is always false, which is correct, and int max. I think the correct answer, well, yes, int max is always true, which is nice. And if this thing is true, if the current value m is true, we'll say r, we will make r equal to that thing. And if it is false, then we will say m equals to that thing. And okay, so why is r always getting smaller? Delt equals 0, m. For this ith damage, we need to see how many times we are doing it. That is equal to m, the total number of turns, the upper bound of this thing, divided by the cooldown. And the ceiling, we have to take the ceiling, m divided by cooldown. We have to take ceiling of this thing and multiply it by the current value of the damage. But this does not work. M here is long, so this whole thing would become a long. So out of bounds is also not an error. And damage dot size, it is n, right? Nice. Shit. The answer is I'm stupid. And okay, shit, now it just keeps on running. And okay, here the answer was greater than long. Okay, so we can go to maximum. And okay, shit, now we are seeing some overflow. Shit, how long would we like to make this thing? 1E15, that should be good enough. And what we can do is we can take the modulus of these two things. Shit, yes, we can take the modulus, but then we will be comparing the modulus with h. H is 10 power 5. Yes. Shit, yeah, we messed up on that one. The fourth last. 1, 2, 3, 4. This one. Yeah, we are messing up here because of, yes, this number being too big. However, this is working, but this might fail in other cases. The only problem here we have is how big do we make the right limit? And I have seen this problem a few times, and okay, we will read about what we should be doing in such situations when there is no correct big R value. Hello, in Sunday, I gave the virtual contest and hell, I was not able to solve any questions except the first one, which was 800 rating. Man, they need a lot of consistency. Yes, you are using custom Vim config or Astro custom Vim config, not anything given to me in WeChat. Nope, custom. I have my own custom as well. Yes, you are a nice man then. Mohit Nishad. Nishad, that is nice. You have your own custom NeoVim configuration, which is nice. You know what is happening inside, which feels pretty cool. And the only reason that this might fail is overflow. Overflow, this right limit. We have to like choose. I don't know how we would choose a right limit that is nice and works for every case. Okay, but 10 test cases is pretty cool. Can we get it in like 20 minutes? So I guess not. And yeah, your previewer is pretty great. Okay, that is by the plugin. That is by the plugin. That is not me. That is by the plugin. Yes, I have built a few projects. Shit, yes. Overflow. Signed integer overflow. That was the only case. Yes, I have built a few projects. I did a few streams where I was building Redis. That was nice. And I have done a few projects before that, but before that, the projects are not worth mentioning. They are not too really good. I guess 10 should be nice. Okay, shit, I think we can calculate how big the right value can be. Let's say we have the maximum health. Makes sense, 10 power 5. We have the maximum health, 10 power 5. And we have the minimum damage, which is 1. And we have the maximum cooldown, which is 10 power 5. So that would be, we need to do 2 into 10 power 5 total damage, 2 into 10 power 5 total damage, and we can do 1 point of damage in like 10 to the power 5 turns. 2 into 10 to the power 5 turns for 1 damage, and totally we have to do this much damage. So in total 10 power 10, that is the maximum R value which we could have. Let's say 10 power 11. But this might still give us overflow. This might still give us overflow. We will see. Damn, I have also built the Redis, but in Go. Yes, shit, I don't know Go. Go is a nice language by Mr. Ken Thompson. Not in C++. I used ePoll there for IO multiplexing. What did you use? I used polling, basic syscall for polling for multiplexing. Shit, for creating the event loop so that we only get the sockets on which we can currently read and write from. So, shit, that is pretty cool. ePoll. Shit, they said that, yeah. Okay, I am stupid. I am stupid. We can make this as big as we want, but we can take modulus. Shit, 1e 9 plus 1 plus 7, because this value is always going to be greater than health, and bool mod equals false. if delt greater than m, then m equals true and delt mod with m, and either this or m, not m, yes, m, and here n equals false. Okay, shit, that is messed up. Uh, delt greater than m or equal to would also be equal. Shit. Uh, uh, del greater than equal to m, and m equals to make it true if we are taking a modulus of this value of delt. Okay, and that is the only thing that we have changed, and we are returning either delt is greater than equal to h or this thing, at least one of them is true. Okay, and m is 1e9 plus 7, which is a prime number. Not, okay, we have to use something else other than m. Um, done, let's say. Okay, now it should work. Yeah, it does work. And this will also not give us any overflow. That is nice. Yep, same. Let's go. Hello. And do you know there is another one which is called iring, which is faster than epoll because it has 0 IO copy, and that is why Dragonfly DB uses it. By the way, it is a competitor of Redis. Shit, so it is also a in-memory database. And yes, I thought that because using, I don't know, I would suppose that using epoll is very similar to using poll, and for doing that, we just have to for doing that we just have to see, yeah, for calling the function we have to go through all the current open connections every time that the event loop runs, I think, which is very not effective. And one more thing, I am your okay from last week. It is so peaceful seeing you investing 34-40 minutes in a question, like me crying in just 4 to 5 minutes. Okay, that is, I suppose, thank you. Just do I less than n and delt greater than h. I less than n. I less than n. Okay, it is working now. I less than n. Where I less than n. Okay, shit, that is pretty nice. And shit, yes, shit. Return delt greater than equal to h. And shit, delt uh has to be smaller than x. We won't get any overflow. I messed up somewhere. I has to be smaller than n and delt has to be smaller than or smaller than h. Only then go inside and do all of this. And don't this part. You don't need that. The nipples who is calling done. Yeah, shit, that is nice. That is nice. That is nice. We are not seeing, we don't even want to know what the maximum dealt damage, what the total dealt damage would be when we are doing M turns. What we need to know is health, if it is going to be greater than H or not. That makes sense. We will keep calculating damage or keep increasing delt till delt is smaller than H. That is good. That is good. That is good. Okay. Today's questions are being very instructive. The last one was also pretty cool about segments. Okay, shit. And certainly this question was not worth 30 minutes. And on to the next question now. We started from final boss. Let's have some fun. Okay, that is a small problem statement. Given two integers n and x, find the number of triplets a and b of positive integers such that ab into ac into bc is smaller than n and a plus b plus c is smaller than x. Satyam 343. Note the order matters. 1, 1, 2 and 1, 2, 1 are treated differently. Okay. And A, B, and C must be strictly greater than 0. So their sum and product of every second number. We have a limit of their sum and a limit on the product. And this can be 10 power 6. Okay, this can be 10 power 6. This feels like dynamic programming. Okay, how n and x and n, okay, n and x. Well, first of all, I would say, should, since they are greater than 0, then n always has to be greater than x. If n is smaller than x, then we won't have any answer, I would suppose. Wait, in that case, we would have, okay, so yes, this value will always be equal to or greater than this value. Yes, that is the thing. Okay, output the number of triplets which follow this thing, A into B. Okay, see, let's try to first solve one problem. We have this X and all of them, all of the triplets, A, B, C, their minimum value can be 1 and their maximum value can be X minus 2. That is their range. So yes, 1 we know from the question, and why X minus 2? Because for any number to have the highest value, the other two have to be equal to their smallest possible value. So they will be 1 plus 1, and to get up, the sum cannot be greater than x. So A in that case can be at max x minus 2. So this is the range for these integers. Should we can just brute force? I think we can just brute. No, we cannot just brute force. For a given A, we cannot go through all the possible B's and then all the no, we cannot do that. There are in total, by the way, around x cube possibilities for these integers. which follow the condition this smaller than x, a plus b plus c. There are in total around this much possibilities, and to be more specific, x minus 2 power 3 possibilities of triplets which are of this form makes sense. X minus 2 possibilities for this, x minus 2 possibilities for this, and x minus 2 possibilities for this makes sense. Yeah, this makes sense. And then for n, for a given n, since a, b, and c can be at minimum 1, so their minimum value is 1. And their maximum value. Minimum value can be 1. When all of them are 1, the smallest sum is 3 that they can achieve, because 1 into 1 into 1 is just 3. But what can the highest value be when we have this a into b, b into c, a into c smaller than equal to n? We want to increase one of them as much as we can increase, right? So which will increase these two terms. Okay, we can do that, and we will decrease this as much as we can, right? In that case, and we want the contribution of a in this total sum to be as great as it can be, in which case we can make b equals c equals 1. Makes sense, this will be 1, and the total thing would be 2a plus 1. Yeah, smaller than n. We are looking for the maximum value, so equal to n. So a can be at maximum, a equals n minus 1 divided by 2, and the lower bound for this value, the lower bound, so n minus 1 right shifted by 1. Okay, okay, and okay, so a, b, and c can have any values in this range and also in the other range. So okay, shit, we have two ranges, one from I included, and second to x minus 2, right? And because of this second limitation for n, the range is 1 included and other is n minus 1 divided by 2. I think we can just take the overlapping intersection of these two things, or we can take the number which is smaller than this. Yeah, so the answer would be minimum of n minus 1 divided by 2, comma, x minus 2, which would give us like how many possibilities there are for these values, for each of these values, and answer would be cube of this thing. That is nice. That is nice, and which is like also in the range. Cube of 10 power 6 is, yeah, it's math. I guess I tried this for some time. Hello, what's up? How is everything going on? Here we have to calculate the cube, and 4 is a square. Yes, just to point out something. Okay, I guess we can have fun. Fun. Okay, DLP int n and x and int or long answer, or not answer, response equals minimum of x minus 2 comma n minus 1 divided by 2 and C out res into res. Shit, if that actually is the answer, that would be, yeah, could be wrong. Shit. How can this be negative? Yes, of course, this can be negative if you don't take in the input. Okay, wrong. when n is 7 and x is 4. And yes, that is the, yeah, n is 7 and x is 4. That is the way that we are taking these two numbers. Yes, n is 7 and x is 4. According to x, our values can range from 1 to 2. X is 4. Yeah, 1 to 2. Those are the only possibilities. Those are the only possibilities. And according to n, the values can range from 1 from 1 to n minus 1 divided by 2, n minus 1 divided by 2, n minus 1 divided by 2, which is 3, and we take 2. So 2 into 2 into 2, 8. Answer should be 8, but it is 4. Answer is 4. 4. We can have 1, 1, 1. That is one triplet. Makes sense. Shit. Okay. 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 2. There are two possibilities for each of these things. And this is one. And then we have a 2. Shit. Yes. Yes. Okay. Makes sense. Makes sense. Makes sense. Because in this 8, we are considering 1, 1 this, and we are counting this one twice. Like wherever there is a 2, we are counting all of those possibilities twice because numbers are same. Okay, shit. The first number can have any value, does not matter in this range. So, which is in this case 2. The second number can have any value. Shit, this is of course wrong. Wrong. Okay, shit. Yes, this is wrong. We cannot have 2, 2, and 2. This disobeys everything that we know about the universe. Shit, this is wrong. Life is good. That is nice. Scene. Yes, that was wrong. That was the mistake. Hello, bro. I cannot understand anything. Beginner here. From Germany. Hallo. Wie bist du? Ich bin heute jeden glücklich. And okay, shit. Yes, we are. Shit. So one number depends on other numbers. If we have chosen one number, it limits all the possibilities for the second number. It limits all the possibilities we could have for the second number, which makes sense. Bro, not German. Okay. Deutsch. Yeah. Uh, okay, so this seems like more like dynamic programming. There are some possibilities for A, B, and C. When we have chosen A to be something, then there are some possibilities for B to be chosen and some possibilities for C to be chosen. The specific order does not matter. So that is nice for the case when the possibilities are 1 to 2. Right, yes, 1 to 2. Then we will have the state like this. Yeah, 1, 2. Yeah, our state would look like this. A, B, and C, and 1 and 2, or we don't even need A, B. We will say the zeroth number, first number, and second number. and none of them can be equal to 0. So 0 is 0, and when their value is 1 and when their value is 2. Makes sense. So and here dpig would mean, what would dpig mean? Number of possible configurations this current number could have. Yes, number of possible configurations where I corresponds to the row and j corresponds to the column. So how many possibilities among I this jth number could have, yes, could have. And shit, also shit, let's, without defining this, let's try to do this 0 0 0 and 1, and x and n are already fixed. X is equal to 4, n is equal to 7, and okay. When our range is just this 1, yeah, when our range is just 1, how many values can this thing be? How many different possibilities could there be with this given n and x? For the first number, there is only one possibility, it can only be equal to 1. And for the second number, when the first number is also equal to 1 or independent. Is this independent? No, no, this has to be dependent. But if this is dependent, how do we know certain thing? Shit, shit. Okay, so this is more difficult than I thought. This doesn't even seem like dynamic programming now. Output a single integer, triplets A, B, and C. Okay, so our initial hypothesis that, okay, so here is the problem. Our initial hypothesis about the ranging, where I1 is the smallest number and the maximum value, anything A, B, or C could have, it is going to be the minimum, the maximum value that any one of them can have. Uh, any one of them can have is going to be minimum of x minus 2 and n minus 1 divided by 2. That is it. This is the maximum value these things can have. And can we just keep increasing this range? Like, what would the answer be when our range is just 1? Yeah, when A, B, and C can have only one value. Okay, let's try to do that. when n equals 7 and x equals 4, let's say 1, 2, this is our range. Actually, the range does not go further than 2, but still, let's say this. And also we have 0 when the range is from 0 to 0. So in that case, answer is 0. But for 1, answer is 1. There is only one possibility, and that is when everything is equal to 1. That is the only triplet. And when 2, at least one of them can be 2, then we have to see how many of them can be 2. Shit, shit, yes. Among these, in how many triplets can we increase the sum by 1, the sum by 1, and still be under x and be under n, where we are calculating the sum has to be smaller than x, and the like crazy product a into b plus b into c plus a into c, this has to be smaller than n. So among all of these possibilities, in how many can we increase just any random one number by 1 and still follow these conditions? Smaller than x, the sum has to be smaller than x, and this alternating product has to be smaller than equal to n. But in this case, it is like with all of them, right? And it will create 3 new possibilities, but that totally depends on in which possibilities are we adding the numbers to. Are we adding the extra number to, and is it always going to be 3? Let's say 3. Here the answer is 3. And okay, and the maximum sum here is 4. And now if we can calculate among how many possibilities can we add 1 so that they still adhere to this principle, and if we can calculate that, then the answer for this thing would be that some number n multiplied by 3, because there are 3 places in each of those possibilities where we could add this extra 1. Yes. And those would only be the possibilities in which we have a 2. All the possibilities in which we have a 2. Maximum sum. What is the maximum sum till now? What is the maximum sum? How many possibilities have a maximum sum equal to this number? Makes sense. And if we have something like this, and A, B, A, C, and A, D, A, B, A, C, and B, C. If we increase one of these numbers by 1, one term will be unaffected, 2 terms will have the other number increased by 1. If we increase A by 1, it would be A plus B, A into C plus B into C plus B plus C. That would be the next, the new thing. Shit. Huh? Yes. Shit. Okay. I think I'm thinking in the wrong way. Let's try to do something with this. Uh, B, if we take B common, we'll have A, C, and 1. A plus C plus 1 plus. If we take C common from this, we will have A plus 1. And what does that even do? That doesn't do anything. Or we could group this in terms of C, where we will have A plus B plus 1 plus S plus B into A plus 1, which is like very similar to this thing. We just switched A, B with C. Shit. This is also, okay, this doesn't make sense. We are on the wrong path here. Yep, these are all the possibilities. Okay, what we do know is we know the range is 1 to some number mx. We know the range. And when we have chosen the first number to be equal to something, to be equal to some number, for the first number, it can be equal to anything, right? It can be equal to anything. It can be equal to anything. 1 to mx, right? It can be equal to anything. And then for the second number, second and third number, they are limited. Like for the sum part, their sum cannot be greater than equal to x minus a. That is true for some part. And for n, we already have a, b plus b, c plus a, c smaller than equal to n. And if we have fixed e, what does that tell us about b and c? Let's factor out a. We take a common and we'll get b plus c plus b, c smaller than equal to n, and we only know a and n at a certain point. This is limiting the ranges for b and c. I think we can ask ourselves a question that when we have a certain value of a, how many possibilities are there for values of b and c? And it is easy to calculate, easy to check out in this condition where they have their sum has to be smaller than equal to x, but the second condition where this alternating sum has to be smaller than equal to n. This is, how do we do something with this? We have chosen a to be equal to something. Okay, b, c smaller than equal to n plus a, b plus c. Problem is this: a and b plus c are a part of this of a term, are making a full term, so we cannot separate a and b plus c. We do know this possibility, so b into c cannot be greater than this number where we only know n and a. We don't know anything else. Shit. 2 seconds for this. We just know n and a. And we are trying to see how many possibilities of b and c adhere to this condition. And on both the sides, we have values that we don't know about. So, yeah. Shit. On both the sides, we have possibilities. Okay, shit. Since we know A, we can take everything to the left, I think, and do something with that. B into C plus plus. Okay, shit. This had to be minus here, but plus A into B plus C minus N has to be smaller than equal to 0. I mean, this term has to be negative or non-positive. This term has to be non-positive, where 0 is also is not positive nor negative. And here we know N, N and A. Can we know B and C? We don't even want to know B and C. We just want to know how many possibilities are there for B and C without going through all of them. Yes, without going through all of them, we need to know how many possibilities are there. Shit. I think here we can apply binary search on one of these numbers. Here we can apply binary search on B. No, no, we cannot. Can we apply binary search? If we see, we do know the range 1 to some maximum value, and we can apply binary search is 1 possible, B equal to 1 possible, where left limit would be N, L, and right limit would be maximum value mx, where both of these are possible, hopefully. Let's say right is mx plus 1, and it is like not possible no matter how what the value of A was. Okay, so R is never possible, L is always possible. Hopefully, yes, L is always possible because it is the minimum possible value for B, and M is never possible. And for the current value of A, when we have fixed one value of A, there is going to be a point. What we do need to know is how many values of B and C follow this condition, and also B plus C is smaller than N minus A. This condition, how many values of A and B and C follow this condition when we have N and A, and when we have N and A, and total values for B and C can be in this range. They cannot be anything other than this. Binary search, why does binary search make sense somehow? For right, what we can do, okay, let's say this is the whole range from 1 to mx maximum, and there are going to be some values of B which are possible. Let's say true, 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 and after a point a lot of values are not going to be possible, but shit, yes, are not going to be possible with the current choice of A equals to some number. And we can figure out this point very quickly using binary search, where we get the first false. But that is not what we need. What we Yes, that is not what we need. What we would like to have is for any value of b which is possible, how many possible values of c can we choose, which would be very nice to figure out. But to do that, we would have to go through all the values of b which are possible, and that is very slow. That is very slow. That is like, yes, very slow. Almost big O of n square time complexity, and we cannot afford it because this number is big. This number is big for a equals to some integer value. For a equals to some integer value, what we can do is we need to figure out how many values of b and c are possible, but in pairs. They are not independent, they are interdependent. The choices, they are not, the choices are not independent. Yes, yes, the choices are not independent. From range 1 to mx, choices are not independent. These are all the possible choices. And I don't have any idea what we can do here. In this question, we have only been able to figure out what the range of A, B, and C can be, but how many possibility? Like, yeah, we only know the range, but we cannot just multiply the range mx cube 3 times for A, B, and C as the knobs which we are turning, because they are not independent. We could have multiplied them if they were independent, but they are not. Making a choice at one place affects the other choice, which is like solving a subproblem, which is if I have chosen something, if I have made my choice of A, then what do I need to know? I need to know how many possibilities of B and C exist where B plus C is smaller than or equal to x minus A, and since we had A B plus B C plus A C is smaller than equal to n, and we have made the choice of A, we need to know how many possibilities of B and C are such that A into B plus E plus B C is smaller than equal to n. That's what we need. And can you calculate this thing directly? If we can calculate the number of possibilities for B and C here and here in a nice way, that would be nice. What could be the maximum value of B and C? Well, the minimum value is always 1. Right? They cannot be smaller than 1. What could the maximum value here be? What maximum value because of this thing could be x minus a minus 1, because one of them has to be very small, 1. And here the maximum value can be when, let's say, c is the smallest possible. It could be b plus 1 plus b is smaller than equal to n, and if we just take b, then a plus 1 into b less than equal to n minus a. So b has to be smaller than n minus a divided by a plus 1. That is the maximum value we can have here. Okay. So, but still, when we have made, so yeah, this just gives us a range starting from 1 to this number n minus a divided by a plus 1, but we don't know for a certain choice of b in this how many possible values for c can we have, right? Yeah, we have no answer to that, no inclination. Okay, I think now we can look at the editorial a bit. 40 minutes is quite a bit long. This was code forces division. Okay, division 4 is going to be, but this was editorial 192 962. Okay, this was by Cry. That is nice. Question number D, division 3. Question D, fun. Okay, there are several solutions to this problem. The easiest way is to just fix A, B, or C. Let's fix A. Yes, that is what we have been trying to do. Since A plus B plus C, AAB plus BAC plus BC has to be smaller than equal to n, we know at minimum A into B has to be smaller than n. On dividing both sides, you get B has to be smaller than or equal to A by n by A. When A equals 1, there are n choices for B. When A equals 2, there are n by 2 choices for B. So that in total, there are this many choices for B. This is just harmonic progression. So overall possible is there are about n log n choices for B. Therefore, we can afford to loop through A and B. Shit. A into B has to be smaller than n, which is how is it true? Yes, at least yes, this has to be true. Ah, shit. So when we have made our choice of A, the number of values, possible values for B that we have to iterate through is not quite a lot. And when we do know, when we have fixed values of A and B, let's say we will know AB, A and B, we can calculate the maximum values for C. Shit, shit. We can do this. We can do this. Shit. And shit. N and X, C in N, and take in X, long, rest equals initially 0. And yes. So for A can range from 1 to less than or equal to N, less than or equal to minimum of X minus 2, comma, N, N minus 1, N minus 1 divided by 2, I plus plus. Let's stop and okay, so we have fixed value for A, which we will say, yeah, A. Okay, A. Now, what are the possible values for B? For B, the possible values can range from 1 till B less than less than equal to n minus A and divided by A. This is the condition. We know the value of A is something and B A into B has to be less than or let's say even equal to n. Let's say even equal to n by a, and b plus plus. Now we have in this loop the values of a and b. With these values of a and b, how many values of c can we have which adhere to both the rules, which adhere to a plus b plus c has to be smaller than or equal to x, and a b plus b c plus a c has to be smaller than or equal to n. How many values of c allow us to do this? For yes, yeah, rest plus equals minimum of x minus a minus b. Yes, and we are just seeing the maximum value of c, maximum value for c that we can have. And when a and b are fixed, here when a and b are fixed, what we will have is c has to be smaller than or equal to first n minus 1 into ab divided by, we are looking for the maximum value, so we will remove less than, divided by a plus b. Yes, and this will give us integer. So n minus ab divided by a plus b. And this number could be negative. Therefore, we will take uh, maximum of this number with 0. Key should have worked be less than or equal to n. Okay, shit. N minus ab. Oh, shit, yes, makes sense. Okay, shit. Okay, this works. This does work. After reading the tutorial, yes, it does work. That is nice. Again, they are saying there are multiple ways. And why did this brute force work? A is this worked because A can, we are ranging A from 1 to at maximum 1 to at maximum 1e6. And for B, what can be the maximum value for B? For B, the maximum value can be n also, but yeah, like there is harmonics. Okay, this was accepted. They are saying it is harmonic series, and there are not enough iterations of this loop to make this out of bounds, or like to give us TLE error, that this is fine. And harmonic series, shit, these questions are very instructive. These questions are very, very instructive. This one, fun. Now that we have A and B, we can see for C how many. Yeah, shit, yes, this is exactly what we did. Therefore, we can afford to loop through A and B, which is explained in this section. Okay, I'll go to the washroom and I will be right back in a minute. And then we will see what are the things that we learned. And yeah, I am back. And just 1 minute. There's someone on the door. 1 minute. Shit. OBS. Yes. And yep, I am back. Yep. Cool. So we did do this one. That is nice. And yes, why did this like brute force work? Because of this possible choices for n, and this is a harmonic series. This is a harmonic series, and there are in total about n log n possibilities. Wait, 50 minutes? That is crazy. Shit, 50 minutes is actually crazy. And sum of harmonic progression here is in estimate around 1 divided by d, which is the number, okay, by which the denominator is increasing in our case, which is, wait, is it d, the common difference of the associated arithmetic progression. Yeah, the common difference is 1, and a is the first term, which is 1. Okay, a is 1, and okay, a is 1. This is 1. So somehow there are not enough. First term is n, not 1, and but the difference is 1. The common difference d, it is equal to 1. Natural log n is the number of terms. There are n number of terms. First term n log square. This is like log of n square. Share. Yeah, but whatever it is, this is within our confines, and we can look through both A and B. This is interesting. This is a nice thing. And yep, yes. Questions have been nice till now. And let's do a few more questions. Yep. Hello. I have done CS50X course, and I am currently doing full stack open course. I am learning to code for the fun of it, and also maybe make a SaaS later. In your opinion, is this good? Yeah, it is good. Now I also want to do lead code to future proof and stay sharp, but now I am confused between how I should approach it, and also in learning C++ or continuing with Python, or better with Python. Better, I would say, get your hands dirty with C++. Yeah, you should go with C++, because start doing Striver. Yo, let's go. Get your hands dirty with C++, because if you know C++, then you know a lot of things. And if you just know Python, then you don't know a lot of things, right? Because Python is way high above from the layer where the operating system is working on, but C++ does not have that much abstraction. So I would say start learning C++, and the growth that will come as a consequence of this choice will be a lot compared to the growth which will come here. And also because you are just learning it because for fun, then yeah, just go with C++. That would be that will give you much more joy. I have experience for pure C from CS50X. Yes, so yeah, you can start with that, and I would say after CS50X, they have suggested like 3 books. CS50X is the book, the C programming language, right? This one. Yeah, I would say just go through this book and read the chapters and also do the exercises at the end of each chapter. This is a pretty cool book, not just for understanding C in more depth, but also how Unix like operating systems work, and use the ANSI version of this book. Yeah, this is pretty cool. This is something you can do. And on to uh different question. Charming meals, let's say Vlad. Let's do Vlad instead. Okay, it is not loading. It is loading. Okay, that is nice. Reset the timer and we'll start it. And yep, everything seems fine. Yeah, good. We can do this now. Vladislav has n cards numbered from 1 to n. He wants to lay them down in a row as follows. First, he lays down all the odd number cards from the smallest to largest, from 1 to the largest. Next, he lays down all cards that are twice an odd number, from 1 to large. That is the cards which have been dealt 2 multiplied by odd number, and 3 multiplied by odd number, and 4 multiplied by odd number, and so on until all the cards are laid down. What is the kth card he lays down in this process? Once Vladislav puts a card down, he cannot use that card again. So if we have been given this and gives this, okay, let's write the whole progression for n equals 7. For n equals 7, first all the odd cards, 1, 3, 5, 7. Nice. After this, all of these numbers multiplied by 2. So 2 and 6. Nice. Then multiplied by 3 is we already have it. This number by 3, no. Then 4. Multiply this 1 by 4. We will have 4. And we have used 1, 2, 3, 4, 5, 6, 7. Yes, we have all the cards. Okay, so 1, 3, 5, 7, 2, 6, 4. 1, 3, 5, 7, 2, 6, 4. Okay, that is right. But how do we tell the computer? If k is smaller than or equal to n by 2. N by 2 here is 3. If k is smaller than equal to n by 2, then it is going to be the nth odd card. Right, and shit, so we can divide this whole thing into different segments, but the wrong thing is that we won't be able to use a card again, which is, yeah, crazy. Which is crazy. Yes. Here in total we are going to have 7 cards. First n by 2 cards are taken over by the odd numbers. Not even that, shit. The higher limit. Yes, the ceiling. Shit, yes, the ceiling of n by 2. Ceiling of n by 2 has been taken up by odd cards. And then we have the even ones, and the even ones have been arranged in a peculiar manner. First, we will always have 2, then we have 6, then we have 4. these two cards are here because of this and this multiplied by 2, and this card is here because this number multiplied by 4. Okay, when we are multiplying all the numbers by 2, let's say we have initially 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, and so on. First, in first go, we will put all of these cards down. Then in second go, we will put down 2, and then 6, and then 10, and the difference is always 3. Difference between them is always 3, right? And then we will put down 1 into 3, then 3 into 3. Shit, since we are only multiplying odd numbers by odd numbers, the answer would also be an odd number, but we have already put down all the odd numbers, so shit, okay, we won't count them. So when we are putting down the cards in the third segment where we are multiplying the odd numbers by an odd number, then we will not count that, right? And we will move up straight to 4 when we are putting down cards which are a multiple of 4, not a multiple of 4, but 1 into 4, 3 into 4, and so on. So first would be 4, and then 3 into 4 would be 12. 3 into 4 would be 12, which is the next number here. Okay, and then the next number would be 5 into 4, which is dot 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 20. And the difference between this and this is 8, and the difference between 4 and 12 is also 8, and the difference between when we were putting down the cards for the second time, we put down 2 and then we put down 6, the difference was 4. And before that, when we were putting down 1 and 3, the difference was 2. Okay, so the difference is just getting multiplied by 2. 8, then it will become 16. Okay, and let's see a bigger number, 84. 84, and we want the card at the 19th position. Wait, shit, this is directly an odd number, I think. We'll put down the 42 first odd numbers, and among them we need the 19th odd number, which is going to be 19 into 2 minus 1. 19 into 2, 38 minus 1. Answer should be 37 for 84 and 19. 84 and 19, 37 makes sense. And for this one, we will have to see. Yo, let's go. Siddhant sir. And okay, so the difference is increasing at this certain range rate, and also the card with which we are starting is also changing. Yes, the starting card. When initially the difference is equal to 2, then it becomes equal to 4, then 8, and then should be 16. When we do this, then the initial card was 1. When we were having a difference of 4, the initial card was 2. And when we were having a difference of 8, the initial card was 4. And hopefully when we have a difference of 16, the initial card should be 8. And yes, it will be 8. Right. Okay. Okay. So we just have to see where uh, in with all of these differences where our kth index lies, and then we will return that thing. Okay, so when we are starting from here and our difference is 1, how many numbers are there going to be laid in this range? There are going to be, since there are n numbers in total and we are starting from here, there are going to be n divided by 2. Should the range is from 1 to n, that is the whole range. So in this, and 1 and n both are included, and we are lying down 1. So shit, yes, we are, since we are starting at 1, we will take the upper limit. So n plus 1 divided by 2 are in this range from total n numbers. And for the second range, it starts from 2 and goes up till n. Yes, goes up till n. And in here we would have n minus this number, minus 2 plus 1. So in total n minus 1 ranges, and the difference is going to be 4. So this number divided by 4, but we have to take upper limit, so plus 3. This, and we will ask, is k in this range? Okay. Let's say we do find that k is in some range where the starting value is s and the difference is d, right? And that would be easy to find out. That would be easy to find out. We know that the first element is this, then the second element is s plus d, then the third element is s plus 2d. Yeah, this is just AP. We will do, if we have k equals to 1 for this value, equals to 2 for this, 3 for this, we will just say s plus k minus 1 into d, which is the formula of an in AP. So that is cool. That is cool. That is cool. And we can just keep moving this thing forward. Yeah, we can just keep moving this thing forward. Okay, nice. N, or it can be big it. This can be big. Let's just in case take long n and k. Okay, we have n and we have k. What we want? What is n? C in. Okay. Initial difference is of 2 and long. Difference is of, yeah, let's use long. Initial difference is of 2 and initial starting point is 1. S equals 1. Now, k, is k in this range? How many numbers are going to be in this range? While k is greater than this range. Okay, how many numbers are going to be in this range? In this range, there are going to be n minus s plus 1, that is the whole range, divided by d, this many numbers. And while k is outside this current range, what we will do is k minus equals n minus s plus 1 divided by d, reduce k, and increase the starting point and also increase the difference, they which are just increase getting multiplied by 2. And if you notice, starting point is always half of the difference, which is nice. So s right shifted by 1, shit, left shifted, and b also left shifted by 1, which is just multiplying them by 2. And when we are outside, we know that current k is a element in the current range, then int response would be s plus k minus 1 into b. And hopefully this works. Shit. Okay, TL, we will get TLE error. Shit, this is not stopping. N minus S, N minus S plus 1, which is the total range, and divide that by D. That is how many numbers we will have in this range. Yes, which is true, which is true. No, which is not true. And we also have to add D and minus 1 because we are taking the upper limit. We are taking the upper limit, and here also plus D minus 1. But even if we didn't do this, K should be decreasing, right? We are reducing K. N is the first number, and yes, N is the first number and K is the second number. Okay, answer correct. Correct. Because K is being reduced by the right amount. Shit, maybe this minus 1 was equal to 0 every time. Minus 0. Okay, cool. Cool. This should be working now. Let's see. Yo, hello. Where can I learn C++ though? Is learn C++ good for this? Should I continue with C by reading the book you recommended or directly learn C++? I would say take baby steps and start with C. Since you are doing this for fun and you don't have any like responsibility to be as good in C++ as you can be right now. So I would say just start with that book because that book is not teaching you just C. It is teaching you also how to program in a sense. And I would say that is a very nice thing. So start with the book and then you can move on to learning C++. And when you are like, you do understand the things which were in the in the C programming language book, this one, when you understand the things in this one, then it would be easier to transition from this book onto the C++ programming language, this book, because this one is a few hundred pages and pretty nice and good for beginners, but this one is a beast, 1300 pages. So yeah, but don't jump directly to this. y- You will probably hurt yourself. Also, isn't Python used a lot more for interviews and SAS backend overall? Is C++ what you recommended? Still, yes, because Python being used a lot more does not matter as much because the personal growth that comes with learning just Python is not a lot. But if you are very good at C++, then you are like good at almost everything because C++ is a very difficult language. And if you know Python, you just know Python and you don't, it is like a typical Python user does not know what is happening under the hood, right? But a typical C++ user knows what is happening. So that is nice. And that is will also differentiate you from all the people who are using Python in interviews, right? So there is also benefit there. And that is nice. That is nice. We did this question. Shit, there has been a lot, right? So we did one more question, which is nice. Now we'll do a few more questions. Vlad and ordering. And what we did in this was we saw in which interval is this k appearing in and just calculate the value in that interval. Now on to after last charming meals, let's say. All right. Shit. Yes, sir. And hello. Slayer is like, shit, you are friends with with you are friends with this guy right here. Just be him. And what do you prefer more, C++ or assembly? Shit. Uh, it it depends on what are the factors which I'm taking into consideration for my preference. If I want to understand low level things, how things are happening at the like processor level, then of course I would prefer assembly. But if I want to write something and get it to production, some project, I will not be writing the project in assembly. For that, it would be C++ or even Python for a project. But yeah, because writing a project in assembly is no. Mm, yeah. Oh, yes. Don't write a project in assembly. But yes, if you do know assembly, how to write assembly, that is a very big boost to yourself. So that is nice. And now charming meals. One more question. Let's go. Check. The Czech cuisine features N appetizers and N main dishes. The ith appetizer has spiciness AI and the ith main dish has spiciness BI. A typical Czech meal, yeah, it is Czechoslovakia. Czech meal consists of exactly one appetizer and one main dish. You want to pair up n appetizers and n main dishes into n meals with each appetizer and each main dish being included exactly in one meal. Your meals shall surprise the diners, so you want the spiciness levels of two parts of the same meal to be as different as possible. The charm of the meal is the difference in absolute values between the spiciness of the appetizer and the spiciness of the main dish. So, a meal consisting of appetizers with spiciness X and a main dish with spiciness Y has this much appetizer. You want to maximize the minimum charm of the resulting n meals. What is the largest possible value of the minimum charm you can achieve? Minimum charm. Minimum charm. We need to increase the minimum charm. Hmm. Yes, let's go with some. This is a nice example. 1, 2, 3, 4, 5. When we have these as the numbers, this is one array, this is one array, and we can pair them up. And we don't need to maximize the maximum one. What we would like to have is keep the average charm, keep the minimum at an average value, which would here I think would 2 if we pair up this 1 with the 3, 2 with the 4, 3 with the 5, and 2 with the 4 and 1 with the 5. Here the minimum is equal to 2. I think that should be the answer. It is 2. Yes. And yeah, 2 makes sense because if we calculate the average when we are maximizing, average would be 2.5. And since we cannot have decimal values, we will have 2. And average, let's say there is a number line 1, 2, 3, 4, dot, 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 and average it is somewhere at some point. Average tells us that some values are here and half around should not average. Median is the thing that matters. Median, shit, yes, median. the median this value, the median this value. If we have 3 here and we have 3 here, let's say we have median values in both, we know for 3, let's take some other example. This one, yeah, let's go. We'll sort this. Let's sort them. The sorted version of this one would be 12, 14, 25, 62, 74, 86, 95. Cool. And for this one, the sorted version would be 20, 51, 62, 7, 71, 70, 71, 72, and yes, 84, and then 92. These are the sorted versions of these two. And the median here would be this, and the median here would be this. Right, and this median tells us that every value to the left is smaller than this, and every value to the right is greater than this. And we have the same thing here. I think the answer would be the minimum of this minus this, 92 minus 62, and 20 minus 60, 62 minus 20, and then 95 minus 71, 95 minus 71, and 71 minus 12. The minimum of this is 30, this value 30, and here we have 38, and here we have 44, and here this is 71 minus 12, that is 59, and minimum value is 30, and answer is 30. That is nice. That does work. Yo, what is a sorted version? Basically, what we are doing here. Sorry if this question seems no question is silly if you genuinely want to know the answer. So yeah, no question is silly. What is sorted version? Sorted version is I'm just calling, we have this list of numbers and I just sorted them. So I'm calling that sorted version. Yes, right. Yeah, that is it. Shit. I think that is how we calculate the answer, but that is very trial and error. I won't be able to prove this method, why this works. Shit, yes. I think this has to do something with the median because every value. Shit. Okay, let's get at this logically because I feel like this is what we will do. Sort the first list, sort the second list, take the median, take the median, take the median, take the median, and if there are like two median values, right, like the median is within a range, then we will have different things. Let's submit and see if this works, and then we'll move on to proving this. in n. And what are the values? Values can be very big. Shit. N is 5000, so we can go n square. We can go n square, but our algorithm is not taking n square time. Still, that should not be why we are rejecting this algorithm. Vector in A size n and B size n, who for reference x, x in A, C in x, and A, B, right. Sort A dot begin, sorted version, A dot end, and sort B dot begin and B dot end. Okay, and now these two things are sorted. If n is even, this is the case when n is odd, and in res or long res equal 0 or not even initialized, then res equal minimum of, we pass in a list. Yes, let's pass in a list. And median A is A n by 2. A n by 2, yes. And median B is B n by 2. Right. And when we are taking median of A, we'll do B dot absolute value of B dot back minus median A. That is one value. And another is the smallest value in B minus median of A, right? That is another value. Another one is absolute value A dot back minus median of B, comma, absolute value of A, first value in A minus median in B. That is our response when n is odd. At the end we will output n, but if n is even, int int lower median in A equals A n by 2. If like n is 4, then we'll take the element at index 0, at index 1, and at index 2. So this is not lower, this is above, and int u lower median in A would be equal to A into n divided by 2 minus 1. Minus 1. Right, and int upper median in B would be B n by 2, and int lower median in B would be equal to B n divided by 2 minus 1, and the rest would be minimum of, we have to go through every single pair manually. Let's shit, I don't to go manually. Let's test if this much is working. Yeah, we won't update rest for n equals odd. Is this working? Yes, for n equals odd, this is working. For the last two, n is not equal to odd. N was equal to odd here, n was equal to 7. So why did this say 24? 24 does not make sense. 24 is like completely wrong, not even close. 7, 0, 1, 2, 3. 7 by 2 is equal to 3. Okay, so we are messing up somewhere. Minimum b dot back minus mda, median of a, and a dot back minus median of b. The smallest values in both the cases. But how did it work here? Here we had 19, 95 and 12, which we were subtracting with and from 71. Right, 71 and 95. That is actually 24. This thing is this thing. Wait, that is actually 24. Shit, okay. Since how long are you doing CP? 6 months, 5 months. I started in June, July. All right, is this is interesting if you know what is going on. Yes, okay, I don't know what is going on because this does not work, and I thought this could work, but no, 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 this doesn't work. This doesn't work. I had my first doubt with this algorithm when I saw this is like 5,000. So we can do some brute forcing. We can go for n square algorithms. That is a lot of time. N square. Okay, and we have a bunch of numbers in one list and a bunch of numbers, same amount of numbers, n in both the lists. And how many possible ways are there? For the appetizer, there are n possibilities, and for the main dish, there are n possibilities. So, shit, which is for just one dish, and there are going to be n dishes. Shit. For the first dish, there are n square possibilities. For the second dish, there are going to be n minus 1 square possibilities. For the third dish, there are going to be n minus 2 square possibilities. Dot dot dot. Shit, this is like a square plus, or this is like 1 plus 2 plus 3 dot 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 till n square and 1 square, 2 square, 3 square. And this is n into n. The total time complexity of this thing is n into n plus 1 into 2 n plus 3 divided by 6, and big O of this thing is n cube. That is just too big. We cannot afford that much time. Yes, we cannot afford that much time. It's guaranteed that the sum of n squared does not exceed 25 into 10 power 6. Shit. 5,000 into 5,000, that would be 25 and 25 million. Yes, we cannot go n cube. That would be too much. But we can do some amount of brute forcing. We can do some amount of brute forcing. Or maybe we don't have to go through all of these possibilities. We can prune the search space and remove a bunch of the things which are like obviously wrong. Okay. Yes, we can reduce the search space, but how? How can we do that? we have, let's say, two number lines which are being represented by a block somehow. Yes, there are numbers, right, like scattered, and what we need is we will be making random, not random, but pairs that, let's say this is not here. Oh shit, this is here. These are paired up. And okay, so the possible differences, what could be the possible differences should for a given difference, for a given difference, can we know that can we know that can we, for a given value of spiciness difference, can we know is this possible or not? Is this the possible, is this a possible answer or not? Not possible answer, but can we achieve a difference of this much in all of the meals? That would mean since we have two number lines, bunch of numbers here, bunch of numbers here, then what we need to see is, since we want a difference of d, then for this number here we will go d units to the right d, and this number, this thing can be paired up with all of these things, because if paired up with them, when there are, then the difference is always going to be at least d, and that is what we are checking, right? So this many possibilities for this, and for this, if we do go to the right, and this many possibilities. Mm, right. But the thing is, this, we are taking the absolute value. So there are numbers on the left too, right? So we will go to the left also by d amount, since we are taking absolute values. Makes sense. So this number cannot be paired up with any of these numbers, and this range is like 2d, right? D amounts in one direction and d amounts in the other direction. So all of these things cannot be paired up with this. Okay, and okay, let's do this thing. And okay, and this is, and it is easy to figure out this range, this whole range, because we have a lot of freedom. We can go n square, so we can figure this out. That would be easy. But when we have this figured out, what we need to do, I let's take an example. The second one, 1 2 3 4 5, right? 1 2 3 4 5, and let's check for d equals 2. When d equals 2, let's check for 3. For 3 cannot have any number in this range. 3 could only be paired up with 1 and 4. Let's keep track of this thing. right? So for 3, not pair and also pair. Let's go from 1 to 3, which makes more natural sense. Right. So for 1 cannot be paired up with 2 and this thing, and can be paired up with any of those numbers. So not pair up with 1 and 2, and can be paired up with 3, 4, and 5. For 2, this 2 cannot be paired up with these numbers and can be paired up with 4 and 5. Not paired up with 1, 2, and 3, can be paired up with 4 and 5. For 3 cannot be paired up with 2, 3, and 4, and can be paired up with 1 and 5. Now 4 can be paired up with these, cannot be paired up with 3, 4, and 5, and can be paired up with 1 and 2. And 5 can cannot be paired up with 4 and 5, but can be paired up with 1, 2, and 3. Okay, and right. What does this tell us about anything? We do know that a minimum difference of 2 is possible. So there should be some information in this. Yes, what we'll keep track of is how many numbers can 1 be paired up with. Shit, yes. 3 can be paired up with just 2 numbers, which are 1 and 5. 4 can be paired up with 2 numbers, 1 and 2. And 5 can be paired up with 1, 2, and 5. 2 can be paired up with this, and 1 can be paired up with these numbers. Okay. And hello, Chad. Oh, wait, shit, the man himself. What should I do to master diff 4? I cannot even solve B in diff 4. He just say at that level, you just have to solve more questions. Like that is the best thing that you can do. Go to any like sheet, get some problems from somewhere. You can use the sheet for getting problems at a specific rating and just keep solving questions. Yes, just solve a bunch of questions. Here's the link. Here you go. Oh, yes, we were like too deep into this lore. So 1 can be paired up with 3, 4, 5. 2 can be paired up with 4 and 5. 3 can be paired up with 1 and 5. 4 with 1 and 2. 5 with 1, 2, and 3. Okay. Mutually exclusive or something. Shit. So there is some, what we have to figure out is there is some property in this table which is true, but and that is why we can have a difference of 2. But if d were equal to 3, then that property would be missing. So let's go with d equals 3. 1, our numbers are 1, 2, 3, 4, 5. Again 1, 2, 3, 4, 5. And we want a difference of 3. This is d equals 3. 1, 2, 3, 4, 5. Not paired and paired. 1 cannot be paired up with these numbers and can not be paired up with 1, 2, and 3, and can be paired up with 4 and 5. 2 cannot be paired up with 1, 2, 3, 4 makes sense. Should 3 cannot be paired up with any number. That makes sense. Should 3 cannot be paired up with any number. So for a specific value of d, if there is some d that we cannot achieve, then no, then the answer would be no. Shit. Okay. For 3 cannot be paired up with any of them. 1, 2, 3, 4, 5. And that is one thing that we can check for. That here 3 cannot be paired up with any number. So therefore, this difference is not achievable because of 3 in this range. But that is just one metric on which D is a difference, a given difference could be failing. What if we had numbers like 1, 2, 3, and then 2, 2, 2. The second row was 2, 2, 2. In this case, let's say we are asking for a minimum difference of 1. D equals 1. Here, 2 cannot be paired up with 2, but can be paired up with 1 and 1. The second 2 can also be paired up with 1 and 3. The third 2 can also be paired up with 1 and 3. So it would pass our this test where we were checking, is there a number which cannot be paired up with any number? But here, uh, this can be paired up with all the numbers. It's shade. We can do this from both the perspectives. From both of the perspectives. If there is a number in this which cannot be paired up with anything, then false. Or if there is a number in this which cannot be paired up with anything, then also false. Makes sense. Makes sense. And the D can range from left to R, and we can apply binary search where the binary search on solution where the solution would take up to n square time for calculating. Okay. Okay. That is wrong. Int n. Yep. And n, and then the values. Vector in A size n and B size n, and for any reference x in A, taken x and A plus with B, and now okay, in L equals, okay, the difference can be actually very big, the minimum difference, because here A and B can be very big, so the minimum difference can be 0, and the maximum difference, the maximum answer can be 10 power 9. The maximum answer can be 10 power 9. Okay, so we will say long L equals 0, and L is always achievable, true, and R is always false, non-achievable. 1e9 plus 7, just yeah, fine. While R minus L is greater than 1, when there is at least one number in this thing, we will do this. Long M equals L plus R minus L divided by 2, and if okay, this M value, if achievable, then L equals M, else R equals to N, and at the end C out L. Now, what is the OK function? We have to write the OK function. We'll be using, yeah, we'll define these things globally, and yeah, like the int A, comma B, A dot, A dot assign N, yeah, B dot assign N to like reinitialize these values, and that is nice. Then our OK function, which returns a boolean and takes in a long n, right? And let's call this m d, which makes more sense, right? Is this difference achievable? Okay, so for int I equals 0, I less than n, I plus plus, and also after getting these two things, we will sort both of them, a dot sort a dot begin and a dot end, and sort b dot begin and b dot end. After sorting, that is nice. After sorting, we are uh, okay, we will check how many for AI, how many values can we take in BI which are greater than AI plus D, greater than equal to, okay, int CNT equals B dot end minus V dot lower bound B dot begin, comma, V dot end, and look for AI plus D. This is the minimum value we can have, and CNT plus equals B. And now values which are smaller, which would be, yeah, uh, upper bound V dot begin and V dot end, and we are looking for a value which is this minus 2. Nice. And not just this, we have to do minus minus on this thing which is returned by upper bound. Upper bound is always like greater. Minus, and okay, can there be like crazy things because of this minus minus operator? I think not. This upper bound could be equal to the beginning, right? Auto IT upper bound B dot begin and B dot end, and look for AI minus T. And right, and then if IT, it if IT is not equal to B dot begin, wait, we don't even have to shit yet. Now we can just do CNT plus equals here and here. From this subtract B dot begin, we'll get 0. Any crazy case? Okay, and we'll say bool rest equals false, and if CNT greater than 0, or if CNT is 0, if CNT is not, if CNT is false, then return false. This D is not achievable, and then return true, but we will also go the other way when we are taking numbers from B. Hence, B and P equals A dot N minus lower bound A dot begin, comma, A dot end, and we are looking for Bi plus D, and CMP plus equals upper bound A dot begin and A dot end, comma, we are looking for Bi minus B and minus B dot begin. And if not C and T, if C and T is 0, then return false. Uh, hmm. This makes sense. Comma 0. Okay, M. Okay, M. Okay, M. M is long. Okay, M does not exist actually. And here also, this has to be. Okay, shit, I expected this to work. 42, 30. Okay, shit. There is only just one error. One error. How are you saying that 42 is achievable? That is crazy. Okay. And before we continue, I will have to go to the washroom and I will be right back in to this question completely. And I'm back. I will read this whole thing. Just one question. And okay, so our thing is good. Our okay function is good. Yes, our okay function is good. And yeah, everything seems okay. Yes, everything seems okay, but no, it is not. Here, the correct answer is 30, but here we are saying 42 somehow, which means there is one more possibility that we are not accounting for. How many numbers the current number can be paired up with. Right. Bi minus D and minus B dot begin. Right. And E dot N minus lower bound, yes, lower bound makes sense. Lower bound here is lower bound okay here. Lower bound gives us the value Yeah, lower bound is okay. Lower bound is okay. Lower bound is okay because the element with which to which lower bound is pointing to is choosable. We can choose that element to get a difference of b. So that is nice. There has to be something else. Yes. When we add all of these numbers to get a difference of 42. This number 12 plus 42, 56, 54. Shit. 54 can be paired up with all of these numbers. That is nice. This number can be paired up with again all of these numbers. And this number 42, 67 can only be paired up with all of these numbers. So this can be paired up with two numbers, 12 and 14, and on the right with nothing. Okay, on the right with nothing. How many pairs are possible? Shit. And this, by the way, is our fourth question for the day, which is pretty cool. This is pretty cool. Fourth question. 1500 related questions. That is nice. So there is also a contest today. And right now I just feel like I am at my limits. 3 hours and 17 minutes. Contest and unrated allowed. Okay, I will do this one unrated. Where is the unrated? Were registered out of competition. Reason rating should be between 0 and shit. Okay, I can register, but my rating will not change. You have been registered successfully. Wait, my rating is too high. Registered out of competition. Out of competition. Like my rating is too high. What does participating in a contest without affecting your official rank or rating? Okay, so my rating will not be affected. That is nice. That is nice. And yeah, that is nice. That is nice. Okay, shit. Charming deals. What do we have? We have some numbers can be. There is something related to inclusion, exclusion, which would work here, it looks like. Because for each number, we are able to figure out which numbers can this current number be paired up with. And we can calculate that for all of the numbers, right? And those numbers should be properly distributable in a way, in the right way. Okay, okay, let's see. Okay, I will do this. I will do this right now. I hope 12, 25, 62. Okay, so to get to a difference of 42, let's say, uh, yeah, for 42, say 12 can be paired up with all of these numbers. Makes sense. 62, 71, 72, 84, and 92. Right. 14 can also be paired up with the same numbers. Let's use text for this instead of writing this out loud. Yo, hello. We just have this question, which is we will do this one. Don't worry. 12. Yes, can be paired up with 62, 71, 72, 84, 92. Okay, that is nice. Then 14 can be paired up with the same numbers, the same set of numbers, 71, 72, 84, 92. Makes sense. And then 25. And yes, here we are looking for a difference of 42. To get a difference of 42, what are the numbers with which the current number can be paired up with? So yeah, 25 can be paired up with 25 plus 42 and 67. All the numbers which are bigger than 67, that is 71, 72, 84, 92. Yep, makes sense. And then 62. With which numbers can this one be paired up with? 62. And also, these numbers can be paired up in like opposite order with numbers which are smaller than the current number. So for 62, I can pair it up with 20. Then the difference would be 42. Makes sense. And for the numbers which are bigger than 42, that would include 102, like, okay, which is non-achievable, right? Like, does not exist in this list. Then 64 can be paired up with, 64 can be paired up with just 20 again. Then 86, we have 86 after that. 86 on the right, there is no number bigger than this, which will give a difference of 42. But among the numbers which are smaller than this, we have, to get a difference of 42, we will take 42, all the numbers which are smaller than 44. 44. So 12, 14, and 25. That is nice. And then for 95. 95 minus 42, that is 53. All the numbers which are smaller than 53. I'm stupid. We are looking for numbers in the second list. So 20 and 51. And here, all the numbers which are smaller than 44 in the second list is just 20. Right. Shit. So yeah, we have like 3 numbers depending on 20. So that is wrong. We cannot have something like this. There is no way that we can distribute these numbers properly. Nope. We are doing code for this question to be more specific. Right here, you can check it out. I feel like I have done a question like this before. Shit, okay. Yes, I have done a question like this, but it was not specifically like this. There were some differences. We have to find a way. We won't, we only have to ask. The only question that we are asking here, given something like this, is there a way to divide these numbers so that, yeah, to divide these numbers properly? And here it is not. We cannot divide 20 among 3 different numbers, and these 3 different numbers only depend on 20. And 42 is a number which is non-achievable. Let's also write side by side difference which is achievable, and that difference would be 30. B equals 30 is something, a difference which is achievable. So for 12 can be paired up with any number bigger than 42, which is 51 in the second list. 62, 71, 72, 84, 92. Okay, makes sense. And then for 14 can be paired up with any number bigger than 34, which is 51, 62, 71, 72, 84, 92. Cool, makes sense. And 25 can be paired up with any number 55, which is 62, 71, 72, 84, 92. Okay, and 62, any 62 can be paired up with 20, and onto the right with 92. Cool. And then 64 64 can be paired up with on to the left with 20 and onto the right with nothing. And then we have 86, which can be paired up on the left with 20 and sorry, with 20 and 36, 56, 51. Makes sense, and nothing. Nothing on to the right, and 95 with 21, 51 and 21, 51 and 62. Okay. And here we can divide these numbers properly. This is a pair. Yep. We cannot have any other number for 42 other than 20. So that is fixed. And since we have 20 here, we will have to do, yes, pair up for 62 with 92 and 86 with 51. So those are also fixed. And therefore, we will have to pair up 62 with 95. And okay, so all of these numbers are taken. It's like 20 taken, 51 is also gone, 62 is also gone, and yep, 92 is also gone. Only these three numbers remain. So for 71, 72, and 84, and all of these numbers have those possibilities. So anyone can take any one of these. Does not matter. I can only solve 1200. I am really slow. I solve 3 per day. Uh, I'm not that good. This is also just my fourth question, which I'm unable to solve. I've been unable to solve. So just say keep solving more questions and also keep studying, keep reading new things, material, like theory is also important, essential. Yeah, yeah. Just this, you can go to this book, Competitive Programmers Handbook, and start reading from this, like some topics which you think you might be not very good at. Like you could read about range queries. There are segment trees there, bit manipulation, something. You can read about things. Hello. Okay, I will read. Yes, bro will read now. That is nice. And shit. You, Eric, the situation is this. For 12, we can, yes, just the final thing. For 12, we can pair it up with these numbers. For 14, we can pair it up with these numbers, 50, 25 with these, and so on and so on, so on. And we need to figure out, is there such a distribution possible given these things? And here, for this like requirement, we cannot distribute these numbers because here 20 is like required by three different numbers. So yeah, this distribution is not possible, but this distribution on the right is possible. That is all that you have to figure out. Generally, how many problems do you solve per day? before you get mentally exhausted. Right now, I am mentally exhausted. Can you summarize the problem if that is okay with you? Yes. So this is where we have landed at the end, but the original problem is this. We have a bunch of, yeah, let's just destroy all of this story. The main problem is this. We have numbers here and numbers here. Both of them have n, both of these lists have n amount of numbers, and we have to pair up all of these with all of these numbers, and we all of the with at the end of each pairing, right? For this number there are 5 different possibilities. For this number there are 4 different possibilities. For this there would be 3 different possibilities, and just like that. So out of all of these factorial, there are in total n factorial ways of factoring, of pairing these up, and we have to figure out the maximum minimum value in all of those possibilities. And what is shit? And for each pairing up, like if you pair this one with a 3, then this is a meal, we are calling it a meal, and the difference among these numbers, 3 minus 1, would be 2, and each pair would have such a difference. And our pairing, like if you were to pair up this number with this with this with this with this, and this with this, that would create one possibility of pairing up. And in this possibility, the difference between all the pairs is 0. And what we need to figure out is what is the, among all the possible pairings, what is the maximum minimum pairing, maximum minimum difference, if that makes sense. Like if you were to pair up this one with 3, with this 2 with 4, this 3 with 5, this 4 with 1, and this 5 with 2. Here, the difference between this and this and this and this is 2, and also between this and this is 2. Yep, and between this and this is 4, right? And yeah, so the minimum difference here is 2, which is the answer, right? I hope that makes sense. This is like a prime decomposition problem. Shit, I don't know what prime decomposition. And shit, yes, that is what you have to calculate. And I think I was not very good at explaining what we want. Yeah. So I suppose, no, it is not prime decomposition. I would we cannot decompose a prime, at least not into factors. Shit, or we are decomposing numbers which are not prime into primes, right? Like 6 would become 2 and 3, something like that. So, okay, I think I can stop streaming because I feel exhausted, and I don't think this is the best way to approach right now. It has been 1 hour on this single question. But yeah, I will be able to figure it out when I am a bit more refreshed. And my thoughts right now are that we have to do some kind of inclusion exclusion here to figure out if this distribution is possible or not. And yes, what if you understand this original problem, what I'm doing is I am seeing what the possible answers could be. Like we could, if on a number line, we could always have the minimum difference equal to 0. Like let's just say we can have a minimum difference equal to 0 and difference equal to d. So this is always like true, true, true. We can have values up to this, dot, dot, dot. And at some point it will become false. So we are like doing binary search here, and for a specific value of t, which is the like greatest value of t, which is true, that would be our answer. Binary search on here. And we can afford n square time complexity for figuring out if a given difference is possible or not, because 5,000. And that is the summary right now. Yeah, shit. I just cannot remember. There was a question just like this where we had to figure out if this, if a distribution like this is possible or not. And yes, it was also something inclusion, exclusion. Here we could go like step by step and by seeing, okay, which numbers are like immediately required. That would be all of these numbers. Uh, like for 64, we can only go with 20. So the possibility is 20. Like there is only possibility for 64, 20. So 20 is like gone. It is fixed. And for this depends on 20 and 92, and 20 is fixed. So 64 can only be paired up with 92. And here 86 can only be paired up with 51. And since 20 and 51 are gone, 95 can only be paired up with 62, and yeah, so on. There are three numbers here, and yeah, sure. Yep, that would be it. Can you use a greedy approach for this? To know like in which part pairing up the highest spice of appetizer with the lowest. No, that will not work. Probably not that simple. No. Okay, I'm gonna try this problem right now. Shit, real quick. Bro is doing it right now, literally. IRL. Okay, let me also think then. And I think there is going to be binary search. But above that, how do we find out if a current difference is possible? Difference is possible. It depends on this distribution, and we can find this distribution in n square time. But how do we know that this distribution is like valid? Shit, I think if there are n numbers, wait, if I add the number of possibilities for all of these numbers, that is like the size of this list kind of thing that we have written here, if we add that up, no, no, that will not work. That might actually work. That might actually work if we add the sizes of these lists It has to be bigger than a specific point. Okay, like, okay, so if we say there are like four numbers, one, two, three, four, that you want five, that you want to pair up with five different numbers, A, B, C, D, E, F, and this can have at minimum, let's say, one possibilities for this. This can also have one, 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 if all of these one possibilities are different from each other. Yes. Hmm. Yes. Should there was a question in a contest which was like just like this. I think you might be able to greedy this by sorting both and matching each AI to BI plus K and find the maximum for overall K. Shit, that I don't know if that will work or not, but I have not thought in this way before. Wait, but this is kind of like what I am already doing, but in from a different in a different way. Yes, in a different way, I would say. Yes. So since we have two lists, one, two, three, and all the numbers are two, 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 right? And here we tried the greedy approach. Greedy does not seem to be working. What to do when you get burned out from CP? Take a little bit of break. That would be nice. Like, yes, if your first list is one, two, three, and the second one is two, two, and two. If you go with, if I understand your approach, then matching each list to this and finding the maximum. We can match this two to three, this to three, this to three. That works. Check. And also here 20, 20, 20. Yes, because yes, I think it's by matching. Should okay, matching them with the smallest value with which they could be matched up with. But this, still that would not work, I think, in some cases. Like if we are matching AI with some value A in the B vector, which is exactly equal to AI plus K, then maybe this value, like maybe this AI could be paired up with a bunch of different numbers, but this exact value, AI plus K, might be the only value with which some AJ value can be paired up with. So we cannot pair up AI with AI plus K, I think. Right now it is like 1400 should have been here, but yeah, 1400, 14. Okay, so yep, that would be it for today, I'll say. And now a little bit of break to get refreshed would be nice. And yep, that would be the end of today's stream. Thank you for being here and bye.